These are the solutions for the study guide for Chapter 4 test. So let's take a look at the first type of problem we'll see. And we're dealing with unit rates. And so it talks about how Ed is going on vacation. He needs to drive 520 miles in 8 hours. What is his average speed in miles per hour? So miles per hour means this. It means a fraction. So we're going to take 520 miles, and we're seeing how many times 8 hours is going to end up going into the 520. And so we want miles per hour. That's what we have here. We just don't have in 1 hour. We have 520 miles in 8 hours. And so again, we're setting up a division problem by dividing the number of hours into 520 miles. And 8 goes into 52. We have 6 times, makes 48. Do the subtraction, we got 4 left over. Bring down that 0, and 8 goes into 45 times evenly. So 65 miles per hour is what our answer is. So let's take a look at another one here. It says 3 pounds of ground pork costs $2. So what is the unit rate? And so what we need to do is find out how many dollars per pound this ends up being. Well, right now what we have is $2 for 3 pounds. But we want to know how many dollars for 1 pound. So as I look at this number, I know what type of number I'm going to end up having because 2 is smaller than 3. So it's going to be a fraction. It's going to be a number smaller than $1. And so I'll set up the problem, 3 into 2. And 3 does not go into 2, so that's the dollar spot. So I know I have $0, but let's see how many cents I have. So 6 times 3 makes 18. And that leaves me with 2 again. So notice how I'm getting that 6 to repeat. Now, since I'm dealing in dollars and cents, I'm going to go one more space over. The reason I do that is because I want to round to the nearest cent in this case. So you see how that 6 is repeating. So this is $0 and 6 dimes and 6 pennies. But this 6/10 of a cent ends up rounding this up. So I'm going to say this is pretty close to 67 cents. So I'll write that as 67 hundredths of a dollar per pound, and that would be my answer. Well, the next one asks us which of these prices, these ones down here, is lower than the unit price for 5 for $9. So first thing I need to do is find the unit price, which is dollars per unit. And so I'm going to set up the problem this way. 5 into 9, see how many times it goes in there. So 5 goes into 9 one time, and we have 4 left over, so I'm going to bring the decimal point up, 0 down, 5 goes into 48 times. So 1.8, so I need to find a number that's smaller than 1.8. So let's check out some of these numbers here. I'll start with this one down here, because I think it's going to be down lower. Let's see if it works. So 10 for $19, so I'm going to divide 10 into 19. Well, I see 10 goes in there one time with 9 left over, so bring down the 0, and 10 goes into 99 times. So this doesn't work. 1.9 is bigger than 1.8, but it's close. So this is definitely not the answer. So let's try the next one. 8 for $16. Well, 8 goes into 16 evenly 2 times. So that number is definitely bigger. 2.0 is bigger than 1.8. So 6 for 10. And I see this one would be the same answer. See, 3 for $6. 3 for 6. See, 3 goes into 6 2 times evenly. So that would not be it either. So it has to be B. Let's check, though. So 6 into 10. 6 goes into 10 one time with 4 left over. Bring the decimal point up, and 6 goes into 40. Well, 6 times 7 makes 42. 6 times 6 makes 36. And that's all I need to do, even though this number continues on. See, 1.6 is smaller than 1.8, so this would be our answer. So let's take a look at the next one. It says to find x and state the angle theorem. So remember, these are parallel lines. These are supposed to be parallel lines here, so we'll just draw those parallel symbols in here. And once we know we have parallel lines, then we can use these angle theorems to find out values of unknowns, like x here. And so I'm going to say x is going to end up equaling 120. Now, how do I know that? Well, I know that because it's inside the parallel lines, and it's on the opposite side of the transversal. So that is an alternate interior angle. And so the way I remember that is if both numbers are inside the parallel lines, that's the interior section of those parallel lines. The exterior section is on the outside. And see, neither of those lines are outside, so that can't be corresponding and it can't be alternate exterior. It's definitely not vertical. It's alternate interior angles. So this next one, though, notice how we've got the parallel lines here, and both of these are on the outside. This is an exterior angle over here. This is an exterior side over on this side. So these are called alternate exterior angles. And so when we look at this angle x here is 60 degrees. So we'll write that in there as well. Well, the next one gives us an angle here of 100, and this angle's x. So x equals 100 degrees, and I know that because these are called corresponding angles. So corresponding angles is when the angle that we are looking at is in the same location as the other angle that we're looking at. So you see how this 100 is kind of in the lower right-hand side as we look at these four angles up here, and the x is in the lower right-hand side as we look at these angles over here. So kind of the same location, and those are corresponding angles. And the next one, these are vertical angles. So vertical angles are ones in which we have the two angles share just a common vertex. So they can't share a side, they only share a common vertex. So you see how the angle comes in and then comes back out to make 150. This one does as well. So they only share this common vertex, and those are congruent angles. Always. Doesn't even matter that the lines are parallel here. You don't even need the parallel lines to show vertical angles. So vertical angles is a real powerful one. Always works, where these other ones here only work if we have parallel lines. So let's take a look at the next type of problem that we'll end up seeing here. And it is this one here. And so over here we end up having number 8, triangle DEF is similar to triangle MNO. And so let's start with two of the sides that we have here. And so I've got DE. And so if I look at this, we've got DE over, and then I've also got DF. Now let's take a look at what DE corresponds to. DE is right here. It's the first two letters. So it corresponds to MN. So I'm going to put MN in the same location I put DE. Now DF is the first and the last letter or point in that where they mention the triangle. And so is M and O. So I'm going to use MO, which is 4 in this case. So I go ahead and plug those numbers in. DE represented 15, and DF is 2x. And then over here, MN is 4. And let's see here, MN is not 4. MN is 7, so let's fix that. So MN is 7, and we had MO is 4. So I didn't even need this number here. This was not even needed to find the answer. And so what we're going to end up doing is cross-multiplying. There's no reducing to do, so we're going to cross-multiply this way. So 4 times 15, and then I'm going to cross-multiply this way. 7 equals 7 times 2x. So we end up with this, 60 equals 14x. So I divide by 14, and when I do that, I can just take out a common factor. And so I see 2 goes into each of these, so that makes 30 over 7, and then I can just reduce the fraction. So 7 goes into 30, let's see, 4 times, with 2 left over. So I can just write the answer as 4 and 2/7 equals x. You got about 4.28, and that would be about the same answer too. That decimal continues on for quite some time, so about 4.28, and then it goes 5, and then it continues on. So those are the same exact answers there. So moving on to the next one, it asks us about a dilation. So let's take a look at dilating figures. And on this one here, it says the figure, we got to dilate it by a scale factor of 3. And so what we're going to end up having to do is take all these points and write them down and then multiply each by 3. And so let's go ahead and start that here. We've got this point here is, we'll call it A, and it is 1 or negative 2 comma 1. And so then we're going to dilate it by multiplying by 3. So we're taking the 3, the scale factor of 3, and multiplying it by the negative 2. And then doing the same thing here. We're taking the 1 and we're going to multiply that by 3. And so that's where I'm getting a prime, and that ends up being negative 6 comma 3. So I'll do that with each of the points. So let's go with point B. I'll just kind of work my way around here. I'll call this one point B. And so that is negative 1 comma 1. And so B prime, when I triple that number, it's going to be negative 3 comma 3. And so taking a look at another one, let's call it C, this one up here. It's 1 to the left and 2 up. So negative 1, 2, so it'll become C prime. And tripling those numbers, I get negative 3, 6. And the last, or next one, I got lots of points here. D, we'll call this one D. That's 2 to the right and 2 up. So 2 comma 2, tripling that number gives me negative 6 and positive 6. Let's redo that again. So it gives me 6 comma 6. And then we go down over here, and this is 2 to the right and 1 down. We'll call that 2, negative 1. It's point E. So E prime is going to end up being 6 comma negative 3. Again, you're just tripling these numbers. F is going to be this point right here. And that looks like it's 1 to the right and 1 down. So 1, negative 1. And F prime is going to be, once we triple that, 3, negative 3. And then G is going to be this point right here. It's 1 to the left and 2 down. I'm sorry, 1 to the right. So positive 1 and 2 down, negative 2. So G prime is going to end up being 3, negative 6. And one last point here, all the way over here, is point H. And that one is 2 to the left, so negative 2 and 2 down, so negative 2. And so H prime is going to end up being negative 6, negative 6. So we just go ahead and plot these points. So 6 spaces left, so that's 2, 4, 6, and 3 up, puts me there. And then I go negative 3, negative 3, positive 3, so that's going to be here. And negative 3, positive 6, so straight up. That's 1, 2, 3, that's another point about right there. And then I go 6, 6, so that's going to be about right here. Let's see, 2, 2, so that works out right there, 6. And then I go 6 spaces right and 3 spaces down, puts me about right there. And then I go 3 spaces, let's see here, 3 spaces right and 3 spaces down. And 3 spaces right and 6 spaces down, puts me about right there. And the last one is 6 spaces to the left and 6 spaces down. And then we get the same figure, just triple its size. And so that's what we end up getting. Well, check out the next tutorial for the next problem.